Electrical systems are fundamental to modern technology and infrastructure. Understanding the basic concepts is crucial for anyone working with or around electricity. This comprehensive guide explores key electrical principles including voltage, amperage, resistance, and their interrelationships. Voltage, often described as electrical potential difference, is the driving force that pushes electrons through a circuit. It's measured in volts. A higher voltage means a greater potential to move electrons, resulting in a stronger electrical current. Think of voltage like the pressure in a water pipe. The higher the pressure, the more water flows. Amperage, also known as electric current, is the rate at which electric charge flows through a circuit. It is measured in amps. 1 amp represents 1 coulomb of electrical charge flowing past a point in 1 second. Amperage is directly related to the number of electrons moving through the circuit. A higher amperage indicates a larger flow of electrons. Resistance is the opposition to the flow of electric current in a circuit. It is measured in ohms. Resistance arises from the interactions between electrons and the atoms of the conducting material. A higher resistance hinders the flow of electrons, reducing the current for a given voltage. Common examples of resistors include light bulbs, heating elements, and electronic components designed to limit current flow. Ohm's law establishes the fundamental relationship between voltage, amperage, and resistance. It states that voltage is equal to the product of amperage and resistance. Mathematically, this is expressed as volts equals amps times ohms. This law is essential for analyzing and designing electrical circuits. By knowing any two of these values, you can calculate the third. For example, if you know the voltage and resistance in a circuit, you can determine the amperage using amperage equals voltage divided by resistance. Conversely, if you know the amperage and resistance, you can find the voltage using voltage equals amperage times resistance. Electrical power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. Power is calculated as the product of voltage and amperage. Therefore, watts equals volts times amps. This equation shows that power increases with both voltage and amperage. A higher voltage or a higher amperage, or both, will result in a higher power consumption. Understanding power is crucial for determining the energy consumption of electrical devices and systems. It helps in selecting appropriate components and ensuring efficient energy usage. Electrical circuits are pathways that allow electric current to flow. They typically consist of a voltage source, conductors such as wires, and various components such as resistors, capacitors, and inductors. There are two main types of circuits: series circuits and parallel circuits. In a series circuit, components are connected one after another along a single path. The same current flows through all components in a series circuit. The total resistance in a series circuit is the sum of the individual resistances of each component. The voltage is divided among the components in proportion to their resistances. In a parallel circuit, components are connected along multiple paths. The voltage is the same across all components in a parallel circuit. The total current is divided among the components, with more current flowing through paths with lower resistance. The total resistance in the parallel circuit is less than the resistance of the smallest individual resistor. Understanding the differences between series and parallel circuits is essential for designing and troubleshooting electrical systems. Electrical safety is of paramount importance when working with electricity. Always follow safety precautions to prevent electric shock and other hazards. Never work on live circuits. Always disconnect the power source before performing any electrical work. Use insulated tools to prevent accidental contact with live wires. Wear appropriate personal protective equipment such as safety glasses and gloves. Be aware of the potential hazards of electricity and take steps to mitigate them. Grounding is an essential safety measure in electrical systems. Grounding provides a low resistance path for fault currents to flow back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. This helps to prevent electric shock and equipment damage. Electrical codes and standards provide guidelines for safe electrical installations and practices. Adhere to the relevant codes and standards in your area to ensure the safety of yourself and others. National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. The NEC provides detailed requirements for wiring, grounding, overcurrent protection, and other aspects of electrical systems. Understanding and following the NEC is crucial for ensuring safe and compliant electrical installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. Circuit breakers are resettable devices that automatically interrupt the current flow when it exceeds a predetermined level. Fuses are one-time devices that melt and break the circuit when the current exceeds their rating. Overcurrent protection devices are essential for preventing overheating, fires, and equipment damage caused by short circuits or overloads. Wiring is the backbone of any electrical system. Proper wiring techniques are essential for ensuring safe and reliable operation. Use the correct size and type of wire for the intended application. Follow proper splicing and termination procedures. Protect wires from physical damage. Use conduit or other protective measures where necessary. Clearly label all wires and connections. Proper wiring practices are crucial for preventing electrical hazards and ensuring the longevity of the electrical system. Electrical components are the building blocks of electrical circuits. Common electrical components include resistors, capacitors, inductors, diodes, transistors, and integrated circuits. Resistors limit the flow of current in a circuit. Capacitors store electrical energy in an electric field. Inductors store electrical energy in a magnetic field. Diodes allow current to flow in only one direction. Transistors are semiconductor devices that can amplify or switch electronic signals. Integrated circuits are complex electronic circuits fabricated on a single semiconductor chip. Understanding the characteristics and functions of various electrical components is essential for designing and troubleshooting electrical circuits. Electrical testing and measurement are crucial for diagnosing and repairing electrical problems. Common electrical test instruments include multimeters, clamp meters, and insulation testers. Multimeters measure voltage, amperage, and resistance. Clamp meters measure amperage without breaking the circuit. Insulation testers measure the resistance of insulation to detect insulation faults. Use the appropriate test instrument for the specific task. Follow proper safety procedures when using electrical test instruments. Electrical troubleshooting involves identifying and resolving electrical problems. Start by gathering information about the problem. Inspect the circuit for any obvious signs of damage or loose connections. Use a multimeter or other test instrument to measure voltage, amperage, and resistance at various points in the circuit. Compare the measured values to the expected values to identify the source of the problem. Follow a systematic approach to troubleshoot electrical problems. Understanding electrical schematics is essential for designing, analyzing, and troubleshooting electrical circuits. Electrical schematics are diagrams that use symbols to represent electrical components and their interconnections. Schematics provide a visual representation of the circuit, making it easier to understand how the circuit works and to identify potential problems. Learn how to read and interpret electrical schematics. In summary, understanding electrical systems requires a grasp of fundamental concepts like voltage, amperage, resistance, and power. Knowledge of Ohm's law, series and parallel circuits, electrical safety, overcurrent protection, wiring practices, electrical components, testing and measurement, troubleshooting, and electrical schematics is essential for anyone working with or around electricity. By mastering these concepts, you can ensure safe and reliable operation of electrical systems.